Yes, sure. So I'm a structural engineer at Arup in London, and I'm also a visiting professor at Cambridge University. The I think it really goes back to my when I first started at Arup. I actually joined a project. We were working with Renzo Piano, and Renzo wanted to use timber on this particular roof. It was an art gallery. Now, in the end, that particular gallery wasn't built in wood, but I got hooked on the material. And so ever since then, I've really been working to try and help wood become a standard material. In the old days, we used to say, shall we build it out of steel or shall we build it out of concrete? And in fact, I'm quite proud. I was down in Australia. I think it was now 10 years ago, and just at the sort of start of that journey and trying to encourage architects and engineers to use wood. And I think now we've got to that. We really have got to that point where wood is now considered a really viable third option. So I find that really exciting.
Fantastic. And how is wood different to the other materials?
So we have to remember that wood was not made for us as a building material. Wood is a plant. It's a tree, and the function of a tree is actually to get water from the ground up to the leaves. That's its raison d'etre. And so the trunk of a tree, we can imagine it like this sort of bundle of drinking straws, this bundle of fibres that sort of carries like a giant plumbing system. And actually, we don't have to be engineers or architects. We all understand how a bundle of straws behaves. We take it in our hands. Imagine all those straws are loosely glued together. It's really strong if we try and squash it or stretch it parallel to the straws. But if we grab that bundle across the width, like grabbing the trunk of a tree, it's actually quite weak. We can pull those straws apart or sort of squash them. And so wood is this amazing material where if we use it in its strong sense, it's incredibly strong and light. And that can have all sorts of advantages in buildings. But I guess it's everything. I like to be realistic, and everything has pros and cons. Just like steel and concrete have pros and cons, wood has pros and cons, and the so that's that fibrous nature of wood has advantages. It means it's light. We can transport it much more cheaply. We need less material in the foundations. But it does make it quite brittle. Imagine the comparison between a matchstick and a paperclip. A paperclip, we can keep on bending it back and forth, whereas a matchstick, it will simply snap. Now, as engineers, when we're designing buildings, we don't want things which will snap suddenly when the wind blows or where there's an earthquake. We want something which flexes much more like a paperclip. And so the challenge for engineers, I suppose, throughout the 20th century was how can we take this wooden material, how can we actually combine it, in this case with steels, because we always really connect wood with steel connections. And so by putting steel at all those connection points between all the beams and the columns, how can we make that overall timber structure behave in a much more forgiving, what we say, ductile way? So the overall timber structure behaves much more like the paperclip rather than like the matchstick.
Yeah, great. That's so good, and it's obviously, as you said, such a different material, being natural. What are some of the differences if you say you're from first principles, if you're designing, say, from a like a post-tension concrete building compared to, say, a timber building? Like, what are these really high-level things that we got to go about when we're choosing timber instead?
So, well, yeah, I mean, what I would say is work with the material. So, and I can give lots of examples of that. So, one is the fact that it's pretty obvious, but it is prefabricated. So, it's not like concrete where we literally cast the concrete on site. It arrives in small pieces on the back of a truck. So, if you have, say, on your drawing, if you look at what we call, engineers call shear walls, these are the things that resist the wind or the earthquake on a building. Those shear walls on the drawing will look exactly the same whether they're made of wood or concrete. But the reality in the building is that that concrete shear wall will be one monolithic thing, which has all been poured together. Whereas your wooden shear wall will be made out of lots of small pieces, likely big CLT panels, which have been fitted together on site. And so that means it's not one big monolithic element, and of course it's a lot less stiff than a monolithic element, because you can imagine all these separate pieces of CLT slightly sliding and rocking and moving against each other. And so, to give you an idea of one implication of that, yes, we can use CLT to stabilize a building against wind. But there's a limit to the height of building that we can do that for. We can do it for the Forte Tower, for example, in Melbourne, but we can't do it for the taller timber buildings, which we're now seeing being built, say Brock Commons, which Fasternet did in Vancouver, or Hout, which we're doing ourselves in Amsterdam. Those are both about 20 stories high, and both of those have got concrete cores. So that's just one example. And then, to give another example of working with the material, I said it's because it's fibrous and it's incredibly efficient and lightweight, and that can be helpful. But I think we all know that if we have a lightweight floor made of wood, it's much more susceptible to vibration. It's pretty obvious why, F equals ma, so F is us walking around on the floor, the force. So if the mass of the floor is lighter, then the acceleration's higher. So wooden floors are more susceptible to vibration. Not a problem. We know how to design around that and make a really good performing timber building, but in order to get that good performance means that we will need to make those bay sizes in our timber building a bit smaller. So whereas in concrete steel, these days we often talk about 9 by 9 or 9 by 12 meter bays. I suppose we could do those in wood, but they would end up being incredibly uneconomic, really deep beams, thick timber slab. So that's what I always say to people, which is just understand the material and work with it. Everything which is in our heads as architects and engineers about the proportions of a standard building is all governed by steel and concrete, which in some ways happen to be similar materials. Wood is a different material. And so if you want to use it, understand it, really understand it and work with it.
Yeah, and I guess that assumption with concrete buildings, when you go for the 12 by 9 meter grid, it was all about hiding the columns and minimizing it as much as possible. And do you think maybe we can compromise on that a bit more because we've got an aesthetically pleasing architectural product?
Yeah, you've actually you've made a really, really good point there. People hate concrete, so we cover it over. Whereas wood, we love it. We love having natural materials around. And so it doesn't matter if it's probably an advantage if we have those smaller bay sizes. And I think the other thing I would say to people is, and this is where one of those other aspects of wood, which is fire resistance, comes in. I would encourage people to do lower rise timber structures. It's not to say you can't do bigger ones, but the great advantage of low-rise timber structures is that you can actually leave the wood exposed from a fire safety point of view. So you can see all that beautiful wood. But not only that, you have saved on the time and cost and sustainability and environmental cost as well of all those finishes. And you can see the wood. So again, sort of work with the material and understand it.
Yeah, of course. And what are some of the advantages of hybrid structures? So you've already mentioned using concrete cores or using steel connections. Like, how do you see timber working best with other materials? Beyond that, even.
Yeah, another good question, actually. I think it comes back to the statement I made earlier, which is that all materials have pros and cons. And so what we're trying to do in hybrid structures is we're trying to combine two materials, say steel and timber or concrete and timber or something like that, and get the best advantages of both. So I think probably it's easiest if I actually give you an example. So I think one of the most exciting areas of hybrid construction in timber is something that we call a timber concrete composite.
Mm.
So if you imagine this in your head, what it might be is it might be a thin concrete slab, perhaps 10 centimeters thick or so, with downstand ribs, but those downstand ribs made of timber. And what we do is we connect those timber ribs and that concrete slab together so that the two are really, really well stuck together. We do that with probably with screws down into the top of the timber, which are cast into the concrete. Now, that sort of construction can match the performance of a concrete slab of, say, a 9 meter span,
Mm.
for example. But normally a 9 meter span concrete slab would be, say, 30 centimeters thick. So what we've done is we've managed to reduce the amount of concrete actually by a factor of 3, but still get the same performance in terms of acoustics, fire, that floor vibration performance. The fact that there is still some mass in there from the concrete can help reduce those vibrations I was talking about that you get on timber floors. And so that, I think, is this sense of it, that what we shouldn't be saying to ourselves is, how can I build my building entirely out of timber? It should be that the overall message for society is, how can we incorporate wood more in buildings? And so that sense of wood and concrete combined could, for example, be a great way of using wood in a taller building. I wouldn't generally advocate building a taller building in wood. It's the, as I've already said, the stability, the wind resisting structure really works well in concrete. To be honest, the columns work best in concrete or perhaps steel, but actually for the floor construction, just imagine if for all those floors can be a hybrid of timber and concrete, and so we can reduce the amount of concrete in the floors by a factor of 3. Now, it should be pretty obvious that actually the floors represent a huge amount of the structural material in the building. So if we've reduced the concrete in the floors by a factor of 3, not only have we done that, but we've also reduced the load, the weight on the columns and on the foundations. So we've reduced the amount of material in the columns and foundations. So I think you can start to see how these hybrid structures can be really, really exciting.
Yeah, definitely. And as we're approaching the end of the podcast now, Andrew, really enjoyed speaking to you today. So what gets you most excited about the future of timber construction?
I think for me, it's that sense of wood as both architecture and structure combined. It's not this sort of old-fashioned sense of building in steel and concrete where we've got this rather ugly structure, which generally we cover over with finishes and plasterboard and fireboard, all of which actually cost money. But if we, going back to like the old Gothic cathedrals where the structure and the architecture combined, so that for me, this combined structure and architecture, and that I think is where for designers the real fun comes in, because your architect and engineer have got to work really, really closely together, because that structure is going to be fully exposed as the architecture of the building, and equally the architecture has got to work as the structure that makes it stand up. So that, I think, is that's the real future of wood, is while yes we can, and everyone's now demonstrated we can build much taller timber buildings, I think the exciting future is the majority of what we build, which is those lower rise buildings, where the wood is everything. We don't need to pay for extra finishes and have all the carbon footprint of those finishes. The wood really is everything in the building. And of course, and to go back to what we said before, the wood then gives us this amazing warm environment that as humans we really love.
If people want to find out more from yourself, Andrew, after hearing today's podcast and they want to find out more, where should they go?
They're really welcome to contact me at Arup. You can guess my email address, which is normally andrew.lawrence@arup.com, or just find me on LinkedIn. Either way, I'm always really happy to. I think at this stage in the wood construction journey, it's just really important to sort of share knowledge, and so I'm always really happy to help on anything.
Well, thank you so much for coming on the podcast, Andrew. It's been an absolute pleasure.